Hi, this is Mrs. Davis. This is APPC Calculus, and we're doing Lesson 1-5, Polynomial Functions and Complex Zeros, and we are on Example 11. All right, this example talks about how you can figure out the degree of a polynomial by its successive differences. So if it has if the differences are equal, the first differences are equal, it's linear. If the second differences are equal, it's quadratic. And third, it's cubic, etc. So if they give you a table and they ask you to determine the degree of the polynomial, that's all they're asking for. But you have to decide which one it is by looking at the successive differences. So I'll show you how to do that. First of all, let's look at our x values. We're going up by 1 each time, and that just means that since these are all the same, the x values are the same, that when I do delta y over delta x to get the differences, to get the differences between it on the rate of change, the x is going to be the same every time. So we don't really have to worry about the x. We can just look at the y. Now that won't be true if you have different x's. You'd have to figure this math out each time. All right, so let's first look at the first differences. From negative 30 to 14, we have a positive 16. And then from negative 14 to negative 12, we have a positive 2. Now, I already know it's not linear because linear, those would have to be the same. From negative 12 to 12, I have 0. And from negative 12 to negative 2, it's 10. Negative 2 to 30 is 32. And then 30 to 96 is 66. So definitely not linear. Okay, we'll put a little linear there for the first differences. Okay, that's the first differences. Let's look at the second differences. 16 to 2 would be minus 14. And then 2 to 0 would be, negative 2. So we know it's not quadratic because those would have to be the same. 0 to 10, positive 10, 10 to 32, positive 22, and 32 to 66, positive 34. So this is your quadratic, which would be the second differences. Okay, so let's see what happens when we go for the third differences. Negative 14 to negative 2 is 12. Negative 2 to positive 10 is 12. Looking good. 10 to 22 is 12, and 22 to 34 is 12. So my third differences, which are my cubic, are the same. So therefore, this is a cubic polynomial because the third differences are the same. All right, so that's an example of doing that. Let's look at the next thing they want us to do is sketching a graph with repeated zeros. Okay, so this is very, very valuable, okay? And there's a lot in this problem because they don't give us all the things we need. We have to do a lot of work. So they say first write a polynomial function of minimum degree whose zeros include the following with a greater than 0. So you have positive coefficients. We have x equals negative 3, multiplicity 2. So that's a 0. So we have a factor of x plus 3 and x plus 3. Then it gives us x equals negative 1 as a 0. So we would have a factor x plus 1. And then it gives us x equals 4, so we would have to have a factor x minus 4. and it's multiplicity 1, both of those. All right, so the degree of this polynomial is going to be a 4th degree polynomial. So I already know that my graph is going to have to point up because it's positive, coefficients positive in front. All right, so it says write a polynomial function. So we have to multiply this all out together. So this part would be x squared plus 6x plus 9, and this would be x squared minus 4x plus 1x, so minus 3x minus 4. Now I'm going to go over here. Here's another review of the table method. I'm going to have x squared, 6x, and 9. And then going down this side, I'm having x squared, negative 3x, and negative 4. So this is x to the 4th, 6x cubed, 9x squared. This is negative 3x cubed, negative 18x squared, negative 27x, and I have negative 4x squared, negative 24x, and negative 36. All right, so let's put that together. I have x to the 4th. I have a negative 3x cubed and a 6x cubed, so that would be plus 3x cubed. I have negative 4 and negative 18 and 9. So that would be negative 9 and negative 4, so that's negative 13 x squared. I have 27 and 24, both negative, so that would be 51. And then lastly, minus 36. So there I have my 4th degree polynomial, all right, written out. It said it makes it, let's make it a function. So let's say that equals f of x. Okay. Now it says, complete the table to help determine the behavior of the function. So now this is saying, if I put in negative 4, what would I get? If I put in negative 3, what would I get, etc. Well, let's go to the zeros. So negative 3 is a 0. It's from up here. And x equals negative 1 is a 0. And 4 is a 0. Now, they're not supposed to be used in a calculator, so we have to go substitute in, and it's easiest to use your factored form for the substituting in. So if I put a negative 4 in for x up here with this, okay, I think it's much easier. We would have, first off, we would have negative 4 plus 3, that'd be negative 1, times negative 1, which is 1, and then that would be negative 3 and times negative 8, so we have positive 24. Putting in a negative 2, that would be 1 times 1 times negative 1 times negative 6. So negative 1 times negative 6 would be 6. If I put 0 in, it'd be 3 times 3 is 9 times 1 times negative 4. So you get negative 36 here. Putting a 1 in, if you need me to kind of tell you how it's going, it's going to be 4 times 2 times negative 3. So 16 times negative 6 is going to be, let's see, is that right? 4 times 2 times negative 3. So you should get negative 96. And then 5 is 384. So kind of help you out with that one, just to save time. Okay. So now it says, sketch the graph of the polynomial. So this is really important. What we're going to do is we're going to put our zeros in, right, on the graph, and then we're going to use what we know about multiplicity and the shape of the graph to graph this. So first, let's see, we go to 4 and -4, so I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so I have zeros at -3. Let's use a different color. -1 and 4. Okay, now my multiplicity for -3 is 2, which means the graph just touches, okay, just touches the function, the x-axis. So we know, we already said it has to be this shape, so I have to come down and I have to go through that 0. I can put a point in here. So I have, when I am at x equals 0, I'm at -36. So we are way down here. So if we made these all smaller, we could do that. So, but anyway, we don't have to have, we're just trying to get the right shape. We would come up here, and then we would go up, and we have to come down, and this one just has to touch because it does not go through because it's multiplicity 2. So check it out. We have the right shape of the graph. Both our limits are going to positive infinity. We have our zeros. And now the only thing we haven't graphed are these maximum and minimums, which right now you couldn't figure out without a calculator. They try to give you some other points to kind of help you out. But basically, these are so big, I don't see how you could make it that great. But at -2, you're up here at 6, so I kind of did that one okay. We already have the zeros. This is the one that's going to be way down there. But we care most about the shape and that we're understanding it, because the questions they're going to ask us aren't going to matter about these maximum and minimums right now. So we've done C, we've sketched. Now on what intervals is f of x greater than 0? So I'm going to use a different color, and I'm greater than 0 here. Now look, it says greater than 0. I equal 0 here, so I'm not going to be able to say that point. And then I am still greater than 0, still greater than 0, still greater than 0 till I get to that point. And then again, I'm going to be greater than 0 over here. So we want negative infinity, and then this 0 was at negative 3. So we have to stop at -3, and -3 is not included. If it was greater than or equal, we would include -3 and have a hard bracket, but it's not. And then we have to go on 3 till it hit that 0, the second 0 closest at -1, so it's -3. And then our other piece now is soft bracket 4, because that's equal to 0 at 4. It'd have to be soft bracket to infinity. So there we have our intervals where it's greater than infinity. I mean, greater than 0. And now, how do we know f of x is greater than 0? Well, we just are looking at the graph. On what intervals is f of x less than 0? And that's simple. Going to use a different color here to show. Let's use red. So less, didn't change it. Less would be this part here. And again, we would use soft brackets. So that would be from -1 to 4. All right, so that was quite a long problem, but a lot of good learning in there.